Good morning. We are discussing about the pressure vessel design, which is required to be carried out for various types of process equipments. Here, we must understand that the vessels which are working for more than one atmospheric pressures are the vessels which are called as a pressure vessels, and these vessels can be of the type of storage tanks, say heat exchangers, autoclaves, reaction vessels, and etc. etc. All these vessels, which are unfired vessels, are always the basic components of the process equipments. And the design procedure is being carried out for these pressure vessels, which are subjected to either internal pressures or they are subjected to vacuum conditions or also subjected to the external pressure conditions. Normally, there are two types of conditions under which the pressure vessels are required to be operated, and they are called as normal conditions, which covers the conditions such as operating pressure, operating temperature, influence of the environment on the pressure vessel, and external loading, if at all it is there on the vessel. Under the transient conditions, the loading pattern consists of the startup and shutdown loading of the vessels, rate of change of fluid temperatures, some emergency operations which are required to be carried out, and possible load of the earthquake if the equipment is being located in the earthquake prone area. The design procedure for pressure vessel is being carried out using different types of codes. There are different codes such as IS code, ASME codes, DIN codes, BS codes, which are being used for designing of the pressure vessels. All these codes are normally used for designing these equipments which covers the areas such as design procedure, fabrication details, inspection and testing to be carried out on these equipments. In India, we are using IS 2825 code which defines all these codes for design of the pressure vessel. While designing the pressure vessels, selection of the material plays very important role. In majority of the cases for general purpose application, mass steel is being used extensively for manufacturing of the pressure vessels. But there are certain materials such as copper, aluminum, nickel and their alloys, and also silver, titanium and nickel. All these are being used extensively for manufacturing of the vessels depending on their requirement. In all these cases, selection of the material normally depends upon the four major factors, and these factors are such as temperature range under which the equipment has to be used, which normally ranges from minus 200 to 600 degree centigrade. The pressure ranges from vacuum to 3000 kg per centimeter square. The corrosion and its effect on the process equipment, and availability and cost of these materials. In a normal case, materials are being divided into three groups. They are in the form of low cost type of materials, which includes materials such as cast iron, carbon iron, low alloy steel, wrought carbon steel. Second group is of medium cost type of materials that includes high alloy steel with a chromium percent, 12% and more, aluminum, nickel, copper, lead and their alloys. High cost alloys generally consist of the materials like silver, platinum, titanium, zirconium, etc. In general, cladding of the second and third group materials on the first group material is being done to ensure the cost economy of the material which are selected for fabrication of these equipment. In some cases, you may come across the materials such as polymers, rubbers, which are being used generally for these equipments in the form of liners or gaskets. After this, you also has to understand the behavior of the material which is required to be operated at the different temperatures. When material is being subjected to the low operating conditions, normally it happens that ductility of the carbon and low alloy steels decreases once the temperature goes below the critical value of the material. Critical value of the material normally depends on the material, its manufacturing method and its treatment. When the material is subjected to a low temperature application, it happens that it fails due to the brittle fracture without giving any type of a deformation. These fractures are normally extensive and leads to the catastrophic fragmentation of the equipment. You also should know that to avoid such type of conditions, sudden section thicknesses or changes producing the notch effect of these equipments are required to be avoided. For such type of application, for the equipment to be operated at sub-zero temperatures, carbon steel is a suitable material and that can be used suitably up to minus 60-degree temperature. When vessels are subjected to the high temperature, the criteria of selection of the material normally is its strength and its metallurgical stability. Strength of the low carbon steel reduces at high temperatures and it is liable to creep, so use up to maximum 500 degrees centigrade. High alloy steels can be used up to 1000 degrees centigrade with proper preconditioning. Material should not deteriorate significantly in service if they are subjected to such elevated temperatures. It is also important that you should control the corrosion rate at which equipments are required to be operated. Otherwise, it may fail in the service life. The metallurgical faults in these materials are avoided by adding some alloying elements in the form of chromium, basically about 3%, which reduces the corrosion rate. For about 600-degree temperature, use austenitic chromium nickel steel and the stabilized grades of the mild steel. Molybdenum improves the creep and tensile strength and reduces its embrittlement. While designing the pressure vessels, we also should know what are the different conditions and stresses involved in the process vessels. As we have discussed, the equipments are being subjected to the various temperature ranges ranging from minus 200 degrees centigrade to about 1000 degrees centigrade. It also is being subjected to the pressure conditions leading from vacuum to the 33,000 kg per Newton meter square kg per millimeter square pressure. In all the equipments, it becomes necessary that to ensure the safety of these equipments are fitted with what is called as a safety wall or the bursting disc, which are being set as per the design pressure values and the temperatures. Value of the design pressure for design calculation always has to be taken 10% more as compared to the maximum operating pressure of the equipment. So vessels with vacuum without breaker plates are normally designed for 1 atmospheric gauge external pressures, and for both internal and external loads, design is required to be made separately, choosing the design which will be safe for the intended application. There are different stresses to which the equipment is being subjected, and they are in the form of ultimate tensile stress, yield stress and creep stress. Design stresses is obtained by considering the factor of safety, and as per the IS ASME BS codes which are based on the UTS ultimate tensile stress, the factor of safety is in the range of 3.4 to 2.35. The codes which uses the yield stresses as the base stresses, the factor of safety is 1.5. These design codes defines rules for design of the vessel shell areas under the steady pressure. support forces in that case, and also the temperature difference of the content are cyclic in nature. There are various design criteria which are being used for designing the pressure vessel. They are based on elastic analysis, based on cyclic load, or which is subjected to the plastic flow of material, or low stress brittle fracture. Low stress brittle fracture in the material normally causes because of the presence of notch, stress concentration at notch, operations at sub-zero conditions, and wrong materials and its treatment. For rupture criteria, design stress is considered as 0.6 to 1 times minimum or average stress of the rupture after 1 lakh hours of the design temperature. For the deformation criteria, design stress is the average stress for 1% creep strain after 1 lakh hours of its operation. In all, the knowledge of creep behavior of the material is required for design temperature above 400 degrees centigrade. As all of you know that the equipments are required to be operated in the different operating conditions, and the corrosion is a common feature of all these equipments. You are required to analyze the factor causing and preventing the corrosion in these equipment, wherein you may find that corrosion rates in the equipment may be predictable, unpredictable, or negligible. Corrosion allowance is required to be added to allow corrosion increasing thickness of the components, which takes care of corrosion of these materials and ensures the design life of the equipment. Allowances of 3 mm are added for materials like carbon steel and iron parts. You are not required to add any allowances if you are using the non-ferrous materials and high alloy steels for fabrication of these equipments. The code says that for the thickness more than 30 mm, no corrosion allowances are necessary.